from an economic standpoint, concrete and masonry are going to be the choice as opposed to steel. Typically, a column will have vertical big bars that run from the top to the bottom. What we want to see is another reinforcing bar wrapped around the outside of those big vertical bars. You cast concrete into the form. After that cures and there's lateral loads put on the building, that column can sway and it can bend, but it won't shatter because of those ties that are holding all the bars in place. They'll have the columns and they'll have the beams at the floor level, and then that panel, that square in between, they might just infill it with a masonry, which often doesn't have any reinforcing in it at all. So when everything is shifting back and forth, that square is trying to turn into a parallelogram, and that masonry shatters. So there's two things that they need to do. When they put the masonry in, they need to put reinforcing bars all throughout it, a grid of reinforcing bars, so it's anchored to the columns and the beams, so it can't shatter and fall out. In addition to that, they need to have shear walls in the building. Typically, we would want those to be concrete, and they're rigid, and they will brace it and stop the building from turning those squares into parallelograms. Base isolation is probably the best system out there. And what that does is that at the foundation level, the building is released so that when the earth shakes, the movement of the building is at a different frequency. And so you might get really fast motions at the earth, and the building will just kind of go along slowly, so you don't get those inertia forces up in the building. If the building is important enough, base isolation will be used on the building, but it is expensive.